All right, what? June 13th. All right, let's do this. Minimum increment to make array unique. You're given an integer array nums. In one move, you can pick an index I, where I is in between, that's the index, and then increment nums I by 1. Return the minimum number of moves to make every value in nums unique. So we need to make it unique. One move, make it unique. Second one, we need 6 moves. So it doesn't really matter. So we'll sort it and then figure out how many we need to move. So the second one, if we sort it, we're gonna get 1, 1, 2, 2, 3, and 7. So we get a 1. And if we have this, then we definitely need to change this, right? And I think, hold on. So there are two ways of thinking about this, right? One is we keep the unique out. So we say we have 1, 2, 3, and 7. And then we know we have extra 1 and 2. And since we can only increment, right? We can only increment. So basically we need to find the one that's, so I have 2. So I wonder, because that's like 4, 5, and 6, right? So we'll definitely try to find the smallest. And it will be the same, right? So if 1 go to, so that's 3, this is 9, so we need 6 steps. It doesn't matter which one go to 5, which one go to 4, but we just pick the smallest. So is that the ideal solution? We find the uniques, we get the smallest that does not exist in the unique array, right? And then we get all of them and try to see which one, like how we can move them into those. Yeah, I feel like that should be the solution, because other ways to do it will definitely incur more, right? Will incur more. So yeah, we're gonna solve it this way, and we're gonna do a, we do a counter, and then we just go from 1, 2, 3, right? We do a counter, and then because it's all the way to 10 to the 5th, so we just go 1. Does it exist? It does. Then we'll, oh, hold on. I need to know which ones are, yeah, okay, so we'll do that, right? And then we'll sort this, and then we go through each one of them, pick the ones that do not, no. How should we do this? We need to find, the value that is smallest value that does not exist in this. Right, we find the smallest value that does not exist in this, and then compare to the ones that needs to be moved. So what we can do is we have a list of this, okay? Then we go one by one. We go 1, it exists, right? And then we remove 1. Then we cannot use that anymore. 2 exists, remove that. 3 exists, and then remove that. 4 does not exist. Then what we need to do, yeah, that doesn't seem right. That does not seem right. Hold on. I think what we need to do, I need to create an array of numbers sorted, okay? An array of numbers sorted. So we can do the counter, and then for each one, we will do that. Like if we have 1, 1, 1, 2, 2, like that, right? We will create this, and then we'll go 1, 2, 3, like start from 1. And if it exists, then we skip, exist, skip. So the first one that does not exist, we'll do this, okay? And then 5, we do this. 6, we do this. Right? 7 exists, so we cannot do. 8, we do this. 9, we do this. So like we just keep going on until we exhaust this. Okay, let's give that a shot. That can be considered as I think that's also greedy. Okay, so to implement this, because all we need is, yeah, we probably can do this. Int exists new int 10,000. 10 to the 5, 1, 2, 3, 4. Yeah. No, 10,000. No, that's not 10,000. 10 to the 5th. 100,000. Ooh, 100,000. Int extras. Oh, I cannot be int. Alright, so it has to be a list extras. New array list. Actually, we can use, yeah, that's fine. And then for n, int n of nums, array.fill exists. Oh, it's a boolean value. I can do boolean. And then if it's just false, right? Then say if not exists n is equal to true, right? Else extras dot. We don't need to. We can just do. Can we do? Can do nah, but I think that will be easier. Just add n. Okay. Right. Once we're done, we say collections.sort extras. Okay. Then we say for I equal to start from 1, I extras. So we say int j is equal to 0, right? So j is smaller than int j. Okay, I should be like while j is smaller than extras dot size. Okay. And int current is we start from 1. If exists current if current does not exist, okay, then we do something. Current already plus plus, right? If current does not exist, then we can say int res equal to 0. Then we say res plus equal to oh, and also we need to see if it does not exist and Oh, current already. Oh, shoot. Okay, so we cannot do it this way. It's fine. So say current must be larger than extras.get j. Why j? We're gonna use I. Right? Then res plus equal to current minus extras.get I. Okay, once we're done, I plus plus. Right? I plus plus. Which means I can do plus plus here. Do not need to do this, do not need to do this. And current always plus plus. Right? If this fails, current is not larger than the current is just current is smaller than, and nothing can do. So we have to increment current. So keep incrementing until we get everything. And then at the end, we can say return res. Okay, let's take a look. I max only use it once, so I think I don't even need this. So 1, 2, 3, 4, 5. Okay. Let's give this a shot. This looks good. Okay. We'll do the same thing, but I said I'm gonna get more ones. We're gonna get at least 3 more ones. 1, 1, 1, and maybe 2 more 2s. Okay, let's give it a shot. Okay, looks good. Maybe I can do all that, or or 100,000. You wanna try that? Let's see what's gonna happen. Yep, that is not right. So we probably cannot do it this way. Okay, that's fine. So we do not use this. We have to use map. We have to use map. Oh, we don't need to use map. All we need to do is if current is larger than, we use max again, or so current is larger than max, so it's definitely larger than, or this, right? Okay, so what I need to do here is let's do max 100,000, and this is going to be max plus 1. All right, so let's give this a shot. Okay, let's put some touch to this. This is 945. Greedy. We do not touch the numbers that are already unique in nums. For the rest, right? For the rest, we simply go from 1 to infinity, and if the current is not one of the uniques, man, maybe it'll be easier to use. I don't know. If the current is not one of the uniques, and if it is bigger, right, than the duplicates, we move the smallest duplicate towards the current value. Okay. One more time. Let's try it. Let's see if this is right. Okay, it's pretty slow. Let's make changes. So the change I want to do is a set integer exists scene new hash set. Okay, so I don't use this. Then we have extra. If we say scene dot contains n, right? Then if it does not contain, then we say scene dot add n. Otherwise extra dot add. And then we sort extra. So if scene dot contains current, right? If it doesn't contain current and current is bigger, oh yeah, we never use this. Okay, let's try this. All right, a different data structure. Oh, it's even slower. All right, so the issue probably is with this, so it's not with scene. Yeah, we go through a lot of this. It's wasting a time, right? It's wasting time. All right. So if we do the uniques, all right, so we have to change the idea. This is kind of slow, right? So if we get two arrays, how about we get two arrays? One is this, yeah, and the other is 1, 2. Okay, so we have two arrays. One is this, one is 1, 2. Okay, then we start from here, and we have 2 pointers. Okay, and if these are the same, then we move forward, right? If this is smaller than a current, this will also move forward. Okay, so now move forward. This is bigger than a current, but do they have anything in between? Right? That's do they have anything in between? Yeah, so this is the smallest, right? And what we need to find is, we call the smallest here. If this is bigger than this, okay, if this is bigger than this, then, well, technically, for whatever this is, I need to find something that just bigger than this, right? So I can search, how should I? do this. Yeah, if it's smaller, then we definitely move, right? Well, until we move something's bigger. If it's bigger, then we compare to the front. We'll compare to the front. That's actually not a bad idea, right? So we move to the first one that is bigger than this, right? And I check with the front. And yeah, because they're all smaller equal to. Then we move to the one that's bigger, right? Then we shall see if this -1, no. What should I check? We check this +1, right? Up into here. Do they have anything for this one? Okay? Do they have anything for this one? And we say, okay, they find some. All right, they find one in it. Still, or we just do gaps, right? We can do gaps. Yeah, gaps. Because we start from 0, right? And then up into whatever we find. So it's like, if we do 0, 1, 2, 3, 7, right? And then we just, this is the first gap. How many values do we have in this gap? All right. And this doesn't have any value, so we don't know on this. We set the first gap. And within this gap, I have how many values, right? And then I compare to the current thing that I have. Okay. So when we have a gap, we'll have a low and we have a high. Okay. So when we get a gap, we'll get a low and a high. Okay. And then we go from here to see how many can fit into this gap. Okay, we find a few that can fit in this gap. Okay, we find a few that can get in this gap. No, we just we find the current and then we say, oh, we can match whatever, find in this gap. And then we do the second, can go in this gap. So the gap just shrinks, right? And then boom, done. We hit everybody in this gap. Then we move on. Right? We search everything so the next one does not belong to this gap. Then we find the next gap. So we'll jump by gaps. So we'll avoid doing this. Okay. Let's try this jump by gap solution. I just did it yesterday. They did 2 release in 2 consecutive days. That is very interesting. Anyway, so okay, solution 1. Solution 2. Yeah, this first solution is too slow, so I'm gonna note that it's too slow. This is way too slow. Okay, so now what we're trying to do is make it faster. Same idea as above, but let's try speeding things up. Hold a second. Alright, let's get back to this. Oh, I think I spelled speed wrong. Okay. Feed the cat first. Let's speed things up. So we don't do scene. We use a list integer uniques. Unique. How do you spell unique? Uniques. Okay. Extras. Then we say arrays dot sort nums. Okay. For this, if uniques, actually I need to add one. Uniques dot add 0. Right, I need to add a 0. Then we say if uniques dot get uniques dot size -1 is not equal to current num, then uniques dot add n else extras dot add n. Okay, so that's that. So now we have uniques and we have extras. So once we're done, we're gonna do again int I is equal to 0. We don't need to do that. Then we will go through the uniques to find int. Okay, so this probably has to be j. Okay, so int I equal to 0, I to 1, I smaller than uniques dot size I plus plus, right? And each time we'll find low is equal to uniques dot get I -1 and high is uniques dot get I. Okay, and then we'll have this gap, right? We can say if high minus low is larger than 1. Right, if high minus low is larger than 1, then we have a gap. Right? We have a gap. Then what we do is we move j forward. Right, we move j forward in the extras. Then we say while it's so high. Actually no, because the low need to move forward as well, right? Because the availables are actually no. This should be +1. This should be -1. These are availables, right? I should say while low is smaller than high, smaller equal to high, right? While it's smaller equal to high, then we'll move low forward. All right, and we'll see if So the current one must be smaller than low. If the current one is larger than low, that is still fine, right? Until the current one, yeah. So the current one is the current extra must be, so this and extra stop get j must be smaller or equal to high, right? If the current is bigger than high, then everybody is small. This gap that doesn't exist. It's not working, right? Okay, so when this happens, right? When this happens, then we basically just say if low is larger or equal to extra stop get j, right? If low is bigger, then we will do it, right? What we'll do is the rest is equal to 0, right? What we'll do is we'll use low, right? So we say rest plus equal to low minus extra stop get j. Okay, once we do that, low will plus plus and j will plus plus as well. And j is smaller than extra stop size, right? And j is smaller than extra stop size, and right? So low minus, and then this one will plus plus, okay? And else, if low, else, if low is smaller than the extra, then low has to plus plus. So low or plus plus no matter what, right? So low or plus plus no matter what. So each one is consider either low is smaller than the current extra, then we low need to move up, or low is bigger, then low will be used, right? So we do that, blah, blah, blah. Once we're done, okay, we get out, right? So we go through the current gap, we get out, and then we move on to the next gap, right? Move on to the next gap. If it doesn't have a gap, then it's fine until we can actually do uniques, right? And then at the end we can say uniques dot add 100, 1001, right? Uniques cannot be resolved because I spelled it wrong. Okay, and then we always have the last one, right? And then we will go, and I think that's it, right? That's it. I feel that's it. Uniques cannot be resolved. Uniques. Okay, let's try this one. All right, let's do this. Hopefully this is faster. Ooh. 36, 36, 43. The last one is wrong. Okay, what deal with the last one? Ah, I see. Okay. It can be bigger. Yeah. We will go through the gaps. We'll go through the gaps within uniques and compare that with compare the gap, right? Compare the gap values in the gap with the current extra. Okay, so we don't do this. Or you do a extremely large value. Something like, you know, math dot or integer dot max value. Right, you do something like that. So you will just keep moving forward. Another thing is the low, right? The low should be not that. The low should be, because otherwise at the beginning we're just wasting time, because we want to get to the extra, right? So it shall be extra plus 1, right? Extra plus 1. So the low shall be the maximum, right? So the maximum of this and extras dot get I plus 1, right? Maximum of this. And then we do this, right? Then we do this, and if this is bigger, then we probably don't even need to do this one, because it will be checked on the low smaller equal to high, right? Low smaller equal to high. And then we can do this. Low would definitely be larger, right? Low is definitely larger because I already set it to be larger. So this check is not necessary, which means we just need to do this, which means I can do plus plus, and we can do plus plus, which means I don't need these two lines, which means I don't need these two lines, right? Low plus plus, and then, okay, let's try this a little bit simplified. Hold on. So examine each gap between adjacent uniques. Okay. So hopefully this one is right. Try this. Ooh. Index out of bound. Should be J. Yeah, extra is J. Yep, I think this is definitely looks to be faster. Uh-oh. Oh, input can be, oh my god. Okay, that's fine. So we just do -1. I did not realize that input can be 0. I thought input cannot be 0. Was my bad. So it has to be a little bit smaller than that. Okay. Oh, shoot. All right. No worries. We will figure it out. I think we need debugging for this one. Where's our IntelliJ? Yeah, we need to debug this. Unfortunately, this is absolutely necessary. Okay. Right, and then main, we have nums. What's our num? The num is this. And then we don't have this. This should be minimum increment nums. Okay. And where do we put? We'll put it here. Okay, run it. All right, uniques. 2, 4, 5, 7. Extras. Bunch of 14s. Okay. So let's run this. This is F8. Can we yeah, let's do this. Also make it bigger. Can we make it bigger? Yeah. All right. So the first one we are going to encounter, j is 0, I is 1, unique dot get. So it's going to be -1, right? And then the other one is going to be 2. So low is going to be 2. Low is going to be 3. Oh, low is 3, right? Low is 3 because I have the +1. Okay, low is 3, and high is, low is 3, high is 1. Yeah, low is 3, high is 1, so it's not gonna work. Okay, so we move on. Next one, low is 3, high is 3. Oh, did I move forward too fast? I is 0, 1, 2. I is 2. Oh, it's 4. My bad. So low is going to be, because j doesn't move forward, j is still 0, right? So low is 3 because 2 plus 1, right? 3, match. Okay, so go in. Low is still 3. J is 0, so extra got j is 2. So rest will become 1. Right? Rest is 1. J is 1. That is 2. So low plus 1. This doesn't exist. So we move out. Okay, so now I is equal to 3. Okay, I is equal to 3, which is 5. J is 1. J is 1, so we're going to point to 4. But that's going to be 4 plus 1 will be 5. Will be 5. Right, low is 5. High is 0, 1, 2. Extra uniques. 0, 1, 2, 3. High is 5, so both are 5. Oh, high is 4. Huh? High is 4. 0, 1, 2, 3. High is 4. Yes. High is 4. So we cannot do this. Right? We cannot do this. So move on. Now low is 6 because I is 4. 0, 1, 2, 3, 4. So basically 5. 5 plus 1 is 6. Now high should be 7. Minus 1. High is 6. So 6 coming in. So we're gonna, yeah, plus 2. So rest will be 3. Yeah, that looks about right. Next, I is 5, so it's 10. So it'll be 7, it'll be 8. Right, 8. j is 2, it's still 4. So that will be 8. Right? High is 9. High because I is 5, so high is 9. So we have 8 and 9. Okay? So we'll do 8 against 2. So I do 8 against 2. So we added 4. So it'll be 7. Next was 9. But the extra, you still need to compare the extra. I see. Okay, I think I know. We need to compare the extra here. J smaller than extra, we still have to do and extras dot get j must be smaller or equal to high. If the j has become bigger than high, then it's a moot point, right? Okay, so we put this one in, and one more round of test. Yep. Try it again. There we go. It's still slow. It's still slow. Okay, I have another idea. Let's try this. So the other idea I have is, once we get out, we don't do this, okay? So once we get out, then we can just sum them up, right? We can sum them up. Oh, can we even sum them up? Can we even sum them up? I don't think we can sum them. We still have to go through them one by one, right? It's just one by one. Because we don't know what they are, right? If we get to the end, now we have a bunch of uniques. Yeah, we don't have any more uniques. So low and high, we're getting this. It's bigger, okay. Then low smaller. How do you make sure that low is only guaranteed to be one bigger than the extra, right? Low is only guaranteed one bigger than the extra. How is this one correct? Yeah, that's in the beginning, it works. I need to jump. Plus, I don't know how this one will work. Doesn't make any sense. Yeah, if you get something that has a gap in between, it's interesting that it's working. Yeah, J move forward. Low could be smaller to the next J. Ah, how is this working? Low can be smaller than the next J. How am I passing? In the gap, I can be smaller. Right? I honestly have no idea how this is even possible, because I'm only at 1. I may be smaller. I think it's pretty weak test case maybe. Hold on. So what I'm saying is we do this, right? And I do believe we don't need this, because I'm gonna add some juicy stuff here. All right, so we're gonna say res okay. Okay, so a res plus this. Actually, we just say low minus this. Okay. And okay, so actually no. Oh, we need to check J again. Right, we need to check J again. J is smaller than extra size, because I need to say low shall equal to max.maximum low plus 1, and I'm going to say extra dot get J plus 1 and low plus 1. All right. Then we can go back up. I feel this is more correct than the previous version. Yeah, I feel this is more correct, and then we have more jumps here. I don't know. It's just slow. Right? It's just very slow. I think this one's more correct. I feel the earlier ones are not correct. Maybe a weak test case. Can you, figure out some test case? And I feel I can, right? Let's say we have 1, 2, 3, right? And then from 4 to the end, right? And everyone, let's say, the first one will maybe like we do another 3, okay? Maybe it is correct, because you can only repeat. I don't know. Okay, what is the good method? Oh wow, this is simple. Sort num sort if I is smaller or equal. How would I smaller equal to? You already sorted it. It's greater than its previous. I don't understand. So basically just equal to, right? Increment is this plus 1 minus this. Minimum increment is plus equal to set. Oh, set the element to be greater than its previous. Hold on. So we sort, and every time I just add this adjust current element. And then the next one, so we adjust the current element. The next one, it's smaller than this, so we need to adjust to the previous. Adjust to the previous, and it's bigger, so we keep moving on. Oh my god. Oh, sort it, and each one we adjust with the previous. Because that's what we need. So we're creating an increment. Yeah, we're making it bigger. So every time you check the previous, you need to be bigger than that. One bigger than that. Holy shoot. Yep. Alright, well, we have frequency. Okay. X is carrying them over to the next value. Duplicates, okay. Frequency count I plus 1 plus equal duplicates. Plus equal duplicates. Frequency counts, okay. Plus equal duplicates. Frequency counts I equals 1. Yeah. And then we'll add duplicates. We add duplicates. This basically says if I have duplicates in the current value in I, right? Then I move on to the next one. I put everybody into the next one. Because duplicates is the frequency. Like I have however many. And now increment duplicates. Next frequency, yes, basically we say we'll move all of those. Oh, we'll move all of those to the next one. And then we move, okay. So this one, avoid, nah, that's no good. Hold on, I don't need this one anymore. So I can turn this off. Okay, so we need a solution. Three. All right. None of my solutions are fast. The solution is in the official solution is very good. Sort nums and modify it in place to create a sort of monotonic increasing array. And for nums I, right? Nums I minus 1 is the smallest max, is the max, right? Is the max value allowed so far, right? Then nums I need to be converted to nums I minus 1 plus 1 unless nums I itself is bigger than nums I minus 1. Yeah, this is good. All right, basically we'll do arrays, sort nums. Okay, rest is 0. Okay, we can delete everything. Okay, and then we just say for int I equal to 1, I smaller than nums dot length, and I plus plus. If nums I is smaller or equal to nums I minus 1, right? Then we say nums res plus equal to nums I minus 1 plus 1 minus nums I, then nums I shall equal to nums I minus 1 plus 1. That's it. I think that's it. Right? That seems pretty much it. Yep. Oh my god, this is gonna be so fast. So fast. That I am happy with. Okay, that'll be it. I'll see you guys tomorrow, and adios.